Who, me?
Yeah. I was talking to Johan if he could hear us.
We hear you.
Yeah, we hear you.
us.
There you go.
Can you hear us?
4 guys. That's awesome.
Hey, Bill, do you hear us?
Yes.
All
Okay,
right.
perfect. Is it loud enough?
Yes.
Yes.
Okay.
How about video? We got video. There we go. Nice. Okay. Jason, you got that? Okay. Shit, he already started. Very good. That's going to work great. Thank you, guys. Okay, who do we have? We have David Henderlong. Raise your hand.
From the trenches of motorsports and Gearhead
Brian,
Central.
okay. Johan.
This is
Johan? And who's the
RealTuners Radio.
fourth guy?
Hi, I'm Todd Merkel.
Todd Merkel. Okay, obviously Merkel Racing Engines. Is that the correct name? Very nice.
Here's your hosts, the Reverends of RPM, the faction of traction. John
okay, the intro's running. We'll mute you guys for actually just I'll not mute you. Just be quiet for a minute.
Mark Dahlquist,
We'll get
Mike
broad in real quick.
James Short, Tom Sewell, Brian Barnhill. This is RealTuners Radio.
All right, we're live. Greetings, everybody. Sorry we're a couple minutes late starting up tonight. You know how much of a stickler I am for the time thing. How are we doing? Okay, yep, live video is all good. So, awesome series of guests this evening. This should be pretty cool. It's been a few weeks since we had some guests. It's time to do another one before we wrap it up for the year. We thought this one was pretty special because if you followed us for the last, oh good lord, a couple years now, I think we were a group of people who wanted to really keep an eye on this 7.3 liter Ford engine that's come out that they're using in the Super Duty applications for their trucks. So we've kind of been paying attention to who's starting to play around with these a little bit or make modifications and kind of start figuring that platform out. And lo and behold, we are so fortunate tonight to have the group of guys that are actually kind of pioneering the way on the 7.3 liter platform. So without any further ado, I think we'll go ahead and introduce the guys here. So first off, we've got David Henderlong.
Hey, Scott.
Can you tell us? Hey, can you tell us who you're with at all, or is this? What can you tell us about what company do I tell people you're with?
Well,
on the side,
I'm a U of M grad, mechanical engineer. My minor is in manufacturing. I'm doing a startup right now for MPE, Michigan Performance Engineering. We're basically doing some 3D printing to support OBR. So we 3D print these covers here. And then
that's cool. You're making the cases. That's cool. Okay.
Yeah.
All right.
So
let me keep going through the. Okay, let me go with the rest of the guys. Or do you want to go ahead and introduce your team? Just give us some names and give us a little background.
Let's go next. Go ahead, Todd.
Hi, my name is Todd Merkel. I am formerly I'm an employee of Ford Motor Company, but that is after 25 years of working in a family engine building business, which I still help my brother out with a lot. And between my working at Ford and his being still running the engine shop, it was kind of a nice fit for me to help him, do the right thing on this engine. And I right away, as soon as it came out, I could see that it was a great platform for performance type work.
Very cool. Who else we got there?
Johan, I'm pretty new in the United States. I've been here for 3 years. I was pretty lucky to run into Todd Merkel within the first week or so, 2 weeks.
Something like that.
We clicked pretty good, and I'm here because of OBR Control Systems. They do engine controllers, engine mapping for various big OEM companies.
Right.
And that's how I got involved with this.
We are hoping to talk as much OBR detail as we can this evening too. So that's one of our primary interests. Although absolutely, we've got to hear about the 7.3, and that leaves one of you left.
Yeah. Hey, it's Brian Wolfe, retired Ford guy. I was with Ford from for about 36 years, and retired as the director of global engine engineering, and retired at the end of 2017. And love Ford, love racing my entire life. So it kind of goes for full circle. When I was in college and that, had very little money, raced a little bit, was fortunate enough to become an engineer, and then had enough money to race, and then retired and opened a small little shop called Willis Performance, and mainly working only with small block Fords and the Godzilla platform.
Right on. Excellent. Wow. Okay. Bill, any of you guys got any other questions for these guys? I mean, I got questions.
I've got
how the
about
heck
4,800 questions, but we're not going to get.
Let's start away, Bill. Yeah. Bill's our Ford guy, and let's let him take the lead. I mean, I'm gonna keep a list of questions, but the ones that don't get answered, I'll make sure get covered. But I'm dying to hear about the well, we'll get to it when it's time to talk OBR here. But go ahead, Bill.
The only other thing I was going to mention is that Brian has done a series of videos with Rev and Evan is how you find those things. One of the former editors of several of the Mustang books, who's now on his own as Revan Media. And if you're looking for information and current developments and background on the 7.3, that's a good place to start for people who'd rather watch videos. I guess the initial question, and we'll start here and then we'll move over to the electronic side, is for our audience that might not be fully up to speed on Godzilla and the 7.3 motor. Brian, this is probably you, but maybe one of the other guys, just kind of tell people what it is, where it is, what it's being installed into, and how it's now beginning to move into the aftermarket. So in 1 minute or no, kidding. Take as long as you want.
Yeah, I'll do my best.
As long as you like.
Okay. So the 7.3 is strictly in the Ford Super Duty, so the 250 and above platforms. It's also used for motorhomes, so just the chassis that they produce for motorhomes. So it's a strictly what they would certify as an over 8,500 pound gross vehicle weight applications. It is a small block. It's 4.5 inch or 4.53 bore space. It's a 9.65 deck height, push rod, 2 valves per cylinder, 8.8 degree valve angle with a 1.8 degree cant, 2.17 intake valve, 167 exhaust valve, hydraulic roller cam. It's a pretty nice tight package. The engine as installed in the vehicle with the full exhaust system, intake system, front and accessory drive, calibrated for I think 91 octane fuel, or pump regular, if you will. Produces about 435 or 430 horsepower SAE net, J1349. If you put that into what an engine builder would classify it as, so dyno headers, no exhaust back pressure, no air cleaner, maybe an electric water pump, premium fuel, optimize the calibration and correct it to standard temperature and pressure instead of what the manufacturers use, J1349, you're about 500 horsepower plus with the engine, and that's pretty stout, I think, for a truck motor. It's gonna be would be really good in a bracket car.
Yeah, so
I mean, that's awesome. Go ahead.
Going from yeah, very much so. And this is an iron block, correct?
Iron block aluminum head, yes.
Yeah, are you able to share anything, or have you been informed about anything about what the 6.8 is going to be relative to the 7.3?
Yeah, the only thing, again, once you're retired, you're pretty out of the loop. It's once you retire, it's almost like you don't have much contact. But I did look at some of the press releases and that, and it looks like it's going to be, basically a sister engine, I think, to the 7.3. And my guess would be it's going to be only in the Super Duties. So something along that line.
Oh, because we hear noises about it being a new engine for Mustangs or F-150s and things like that. So who knows? I guess we'll find out. You guys made some noise on the internet recently with a short video that you ran on a twin turbo installation. Our audience is all about turbo installations. Can you give us a little overview of what that was and where you are with that end of the process?
Well, that project started out as, I could see right away that this Godzilla platform was going to be fantastic for racing. And originally we had decided we were going to just put one on the dyno and get started on that project. And last Wednesday, I guess we decided we were going to hatch a plan to, hey, you know what, let's just put some turbos on this thing and see what it does. So a bunch of next day air charges later, we had all the parts we needed. The three of us went to New York, and in one day we installed a turbo, and the next day we made a few pulls. We would love to have kept going on that project that day, but we had to catch a flight back to Michigan. So originally it didn't start out as a turbo project. That whole thing only took 3 days.
So at what point do you become concerned about the additional cooling slits that are in between the cylinders when you start pushing boost up and start making cylinder pressure and the block starts moving around? At what point does that become a detriment as far as a crack forming?
It will eventually probably give us trouble, but at the 15 psi of boost we ran for this last little go around, it didn't present any problems.
Yeah, if I could just add, Todd, that I thought was really impressive is that was they didn't even take the valve covers off that engine. Right?
Yeah.
I don't know if that popped really clear, but you changed the fuel injectors.
We put bigger injectors in it, and we literally did not take the valve covers off.
Plugs.
Oh, we get the plugs.
Yeah, we got the plugs a little tighter. I think the stock gap is 40 to 50 thousand, so it's quite wide.
Yeah, we squeezed that down a little and let her eat, just the way it was.
So to answer your question, I think that's the work like Todd's doing, and also we're doing at my place in Michigan. It's a lot of fun to be a pioneer on the platform, but part of that is you got to find out where the weak link is, and we'll find that out because Todd's done again 1114 horsepower is pretty impressive, is very impressive, and then we're going to be doing one with a Whipple on it as well. Hopefully within the next week or two. I initially had some issues on the engine that I was doing. It's not the stock as one Todd did, and has mechanical roller cam and a shaft mounted rocker valve train. In the first go around of that, I just had a little issue with retention of the rocker arms. So I got that corrected, and hopefully have that taken together in the next week or two and have that on the dyno. We'll see how that does.
Yeah, we're all looking forward to that. And as far as the turbo engine goes, in the next week or so, we're going to start working on that again, cranking more boost into it. And I think it may need valve springs is probably the next thing I'm going to put on that. And we're going to take it from there and just start finding weak links as they come up.
How much room is in that block for bore and stroke? How big can you go?
There's not really any room for a larger bore. Ford, to their credit, they're keeping it inexpensive and light as possible. So there's not a whole lot of room there for larger pistons. If someone were so inclined, there is a lot of room for more crankshaft, however. The cam is quite raised. There's just a mile of room around the crankshaft for more stroke.
Yeah, as a matter of fact, in the motor that I did, we put a MGP aluminum rod in it, and there was no clearance issues whatsoever to worry about. So if you had a steel rod motor, you could go, as Todd said, I think significantly more.
Well, that's something I hear there too, is a lot of crankcase room, which allows air movement in the crankcase, and that's good for ring seal. So I like to hear that.
Yeah, there is a lot of volume down there.
Yeah, that's an interesting point. We were talking a little bit on a sidebar. One of our members here on the podcast is building a new motor, which is a 513 cubic inch based on, I can't remember the letters and the number. I'm sorry, I have to take care of my dogs for a second.
That's fantastic.
The discussion was basically about one of the problems that I see with the LS is the LS Chevrolet is a lack of air movement in the crankcase, and there's certain challenges to getting the rings to seal in those that you wouldn't deal with other engines. And I like to hear that this one has a little bit of room down there, because I believe that's a good thing.
Yeah, not just throwing massive catch cans and just trying to deal with everything on our turbo LSs that is just considered norm these days.
Well,
when we ran it on the dyno, we had completely open valve covers. There was not a
No vacuum
crank,
pump.
Yeah, no vacuum pump.
vacuum pump, no crank ventilation.
No catch
insulated.
can.
And we didn't see a drop of oil coming out of those valve covers.
No.
Right.
And we dynoed it.
Even at that
Quite a lot.
high boost. Yeah.
Yeah.
Well, relatively high.
I suppose that has something to do with the fact that that's an engine designed for a heavy-duty truck application. So it's built to handle a lot of heat, a lot of consistent load, a lot of all those
Continuous
things.
use, yeah.
Yeah, heavy.
Do you guys think that Ford will turn this into a marine engine? There's kind of a...
I'm fairly certain that that's going to come to pass. The marine manufacturers are usually several years behind on platform, but I fully expect that this will make a fantastic marine engine.
Cool.
We had a few inquiries by private people who want to install them in the private boats.
Yeah, already.
Yeah.
Well, business opportunity strikes, and there are now crate versions and long box versions being sold directly by Ford, correct?
Yeah, the dealers, you can buy any engine, any Ford vehicle, from your over the service counter, right? And but Ford Performance basically also has a crate engine offering, which is basically the same as a complete engine that you would buy from the parts counter at the Ford dealer.
And they have a performance pack type situation, so you can install it as a retrofit in something that wasn't originally the same vehicle with the same engine.
Well, they don't have I think right now the only thing Ford Performance offers is the engine itself. And this might be a good idea to talk about putting it into something that it wasn't in to start with, which would be how do you control it? And I think that's where the OBR system comes in with the wiring harness switches, pretty, hook this up to positive, hook this up to negative, plug it into all your factory sensors and go type of thing. And
that was my not so clever way of going to that conversation. So let's go ahead.
So do you want to talk about the Euro 8?
Yeah, we do an engine controller that is used for both motorsport and automotive development. Different types of software depending on which customer it's used by. And for the Godzilla project, the plug-and-play Godzilla kit, we use the motorsport version, which means it will control everything on the motor. The oil pump, the scent throttle body, the digital signal in the throttle body. It controls the camshaft, everything you got on it.
Oil pump.
Yeah, oil pump, variable oil pump. It also does the mass airflow sensor, but we don't put that in our harness. That's an add-on, because there's too many problems with it. If your air filter breaks off, it's going to give you wrong readings. We can do it if you request it, of course.
Will it work in speed density without a mass airflow sensor?
Yes,
yeah, of course.
yes.
Yeah.
That's how they're running it now with Boost, right?
Yeah, we got two different versions or two different calibration we send out to our dealers, and that's Alpha N if you don't want if you don't want a map sensor on it, but we deliver it with a map sensor. The engine does not come with a map sensor OEM, so we deliver an aftermarket map sensor that you put right on it. With a little.
There's no map sensor in the final product. That's interesting. They rely entirely on mass airflow.
Yep.
Indeed.
Wow, cool.
Yeah.
Okay.
Yeah.
Now we're
Ford's
getting
been doing
somewhere.
that for a while, haven't they?
Say that again. I'm sorry.
I said Ford's been doing that for a while, relying solely on the math and back calculating predicted map.
Yeah, I think that's
Depending on if it's turbocharged or normally aspirated engines.
Correct. Yeah. All the naturally aspirated Coyotes are all calculated map, I believe.
Yes.
Yep.
Well, I don't know all of them, but what I've seen.
By way of introduction, that was Brian Barnhill. He's our resident guy with OE experience and also a mechanical engineering degree and that sort of stuff. So whenever there's math, we get Brian involved. I'm the lawyer, so no math over here.
And the software also comes with all the motorsport features we got. So paddle shift, traction control, lambda control, built-in data logger, all the things we've been running with since 3 years before I was born. I think yeah, this started in 79 or so. You got 5 engine units inside one, so there's 5 calibrations. Anything you want, you got it 5 times. On the fly,
Nice, okay.
full throttle, down the straight, you can switch calibration.
Change on the fly, right. Beautiful. Yeah. Excellent. Is it based on any existing systems out there? I heard through the grapevine, maybe Bosch guts here? No, it's not.
We buy our electronics from EFI Technology in Italy.
Got it. Okay, beautiful.
Who makes the hardware?
Okay.
That might be the confusions.
The hardware is EFI Technology in Italy.
Got it.
And
okay.
This is a spin-off of OEM product. You will find this in other OEM products.
Gotcha.
Other road car, where we got a slightly upgraded version with data logger and Ethernet connection, which they don't use in the OEM.
OEM, correct. Okay.
Then we got our own software with all the motorsport features.
Do you have high current coil controls on that ECU there, or do you have external igniters or work with smart coils, or how's the ignition work?
Software selectable. You select you got logic coils or direct coils.
Sweet.
So and that's the nice thing about this. There's 2 things on the Godzilla that are kind of new and and unique. One is the cent throttle body. So if you bought one of the crate engines and you wanted to use it as as it is, just put it in and plug something in. The cent is kind of a reasonably new protocol for communication.
Sure. So single wire serial, is that right?
Single-ended nibble transmission.
Got it. Okay.
And then the other thing is that these are, if you will, the dumb coils. So you need something powerful enough to drive the coils in this
coil driver,
as well.
Oh, so you're actually driving the coils directly with no igniters or anything then, right there, natively on the huge advantage.
You can select in the software the current amount that you want, and set them up with 6 amp or so, and I think we can put them up to 20 amps. So.
Which is all the more impressive thing.
The more boost you want, the more.
Really, yeah. So and you're getting right up to the IGN 1A territory. Okay.
And that's what's impressive about what Todd, and Dave and Johan and Scott did. You think about what they accomplished, 1,114 horsepower, and they used all the factory hardware that came on the engine.
Yeah.
Everything.
Yeah. What guys on that test?
Say that again, Sam.
What fuel were you guys on that test?
Pump fuel in the beginning?
Yeah, we did all the normally aspirated work with, super from the local gas station. And then in order to not have a failure, to stop the testing before we really got going, as a safety measure, we ran it on Sunoco 112 octane race gas when we were making the larger power numbers. But that wasn't necessarily because I think we needed the octane. We just wanted to prolong our time of running the engine before we had a failure.
It wasn't an octane prove-out test. It was
it wasn't exactly.
There was few hours before our airplane, so we were very time sensitive at the moment.
Well, yeah.
So that makes sense. So you put a safe fuel in it, and just to be able to do higher pulls. Are you saying that up to 1 bar with the intercooling that you had on it, you might have been able to get away with 93?
I believe that to be true. Yeah.
Interesting.
It all depends on how long you want to make that power. This is a dyno test. It's fairly short. If you want to do it for a minute, 5 minutes, things.
Yeah, you need the better fuel.
Okay. So you guys did the NA stuff. What kind of timing numbers for MBT do you see NA on?
Naturally aspirated.
Yeah, yep. I'm really curious to see how efficient the heads are, that type of stuff.
I don't think it's terribly high.
No, it's about 24 to 25 degrees.
Yeah.
So it's a really efficient chamber then.
Yeah.
Yeah.
Moderately efficient. Yeah.
Centrally located spark plug, and it's tight.
But it also depends on your cam timing. Change the cam timing. You can change it from 0 to 63 degrees or something. We usually don't run that high numbers.
Yeah, but even when I was changing the cam timing, when I was doing the work, I kept carrying around and put, say I should be able to put a little bit more lead in this and make more power. I was like, okay, well, I'll back it back down.
Yeah.
In fact,
Yep.
I think when I was the one engine that we did with the mechanical roller cam, and it made like just under 8, but we ran out of fuel injector. That we only had 25 in, and I think I went to 27, and it didn't improve it, so I backed it back down. I should have probably rented it 22 or 23 and see if I lost anything, but then I had the rocker failure.
Gotcha. Yep. No, that's great to hear, man. That's kind of groundbreaking. You're the first guys to share what kind of timing numbers the rest of us are going to see in 10 years when we get to put our hands on these.
I think it's going to be sooner than 10.
Well, actually, I'm hearing it's in a month or two, maybe for me, but we're going to find out here. I got somebody kind of kicking around the idea. My next question, what Reluctor wheels did they end up putting on the crank and cam? What patterns did they end up with in the final product?
Yeah, that's you, Johan.
That's the pretty standard, just like all the other ones, 60-2 on a crank.
Yep. Okay.
I don't know what.
Well, that's a departure for Ford. I mean, I don't know how many other you worked on the Coyotes or not. I mean, that's a departure for Ford. The 60-2 pattern now. I guess I shouldn't say that. Maybe they've been putting that on the EcoBoost or the engines. I don't. But
yeah.
I haven't seen anything else in 60-2.
Yeah, I'm used to Coyotes and modulars at 36-1. Right. So
you're showing
very
your
cool.
age.
Yes, 47.
I'm used to points.
Used to carry a matchbook even though you didn't smoke. Yeah.
Indeed.
So I guess what's on the cam then? What Reluctor wheels are on the cam? Is there a really custom pattern there?
It's a custom pattern, and to be open, I'm not sure, you may know, but there's like 4 different leading and falling edges, and I don't.
There's nothing else on the market that resembles it because all the angles are a little bit different, so we can't really say it's that type of trigger.
So, Johan, do you know if there's at least a scenario where, depending on the cycle, that you can pull the level high or low on the cam signal, and then it alternates every pass? I mean, so a lot of the standalones out there, the more basic ones, will. Even if it's a multi-tooth cam sensor and they're really decoders are only really set up for single pulse, some of them will simply look at the high or low level at a given crank tooth number. Do you know if there's any thought like that in there for that?
So we don't operate like that. We always do very dedicated embedded software for the particular engine
decoding
you're working with.
Sure.
And then you choose the engine in the software. So you open your setup calibration and you choose Godzilla or a
that's
Coyote
simple. Nice.
Or even LS.
An LS or V10,
nice.
Whatever engine you got. All this standard stuff with 1 pulse on the cam and all the standard crankshaft trigger patterns. You just key in what you got and it works.
Is there any chance you brought some screenshots or software to look at or to share?
Yeah.
Are you feeling that? You practiced up?
I haven't really practiced in using your software here for sharing.
Are you on? We're using your setup right now, so all you have to do is Barnhill. Who's the expert on the sharing here? You go to. So for me,
use mouse over RealTuners and go to the bottom and click share.
Share, yeah.
And then it'll show you all your screens you can share. And you can choose just to share a specific app as well.
There, he's got it. He's all over it. Johan, I figure if you can develop your own ECU, you probably can figure out RingCentral. You're doing good, buddy.
I didn't develop
doing good.
ECU, but,
this is cool. I don't know about you guys. I absolutely get off on seeing new ECUs and things that are coming out. So this is we can talk plenty of Ford questions, but we need to check this out big time.
This
is some pretty cool stuff.
While we're pulling this up, does it have the ability to drive some of these more difficult to drive injectors directly as well?
Which injector are we talking about?
High current is my guess. He's talking about the things like the billet atomizers, because the first thing that's going to happen, Johan, is one of us is going to want to put this on a pro mod on methanol, and we're going to need 1,300 pounds of injector per cylinder per hour. So.
We do high impedance injectors only, and direct injection. That's with an external module if you want 8 cylinders.
Got it. So we could use a driver box to drive low impedance injectors if we wanted to, then an external driver.
Yes.
That would actually figure it out.
And if
Wonderful.
we wanted to run 2 sets of injectors,
Yeah, how many injector outputs?
16. And when we
Nice.
run DI, we use the 8 injectors for PFI and the other 8 for DI.
So I guess since you brought up DI and that's a topic that comes up a lot, as far as calibration, I'm assuming that's the same for fuel pump calibrations and stuff like that. We're more or less reliant on what you guys have defined already, which is really the case with DI in general. I don't know very many people that have the ability to define a fuel pump characteristic themselves. But I'm assuming you guys have some of those defined already in the software that you would just pick from.
So the GM.
Yeah, so we don't have a system with drop-down boxes where you select that particular injector. That's, can you say, the downside to our software. You have to know which type of sensor you're working with, what your function.
I was talking on the fuel pump for the DI because the fuel pump timing and all that.
Yeah. So usually we got a lot of calibrations from all the different projects we have done, and we work with the customer, figure out what they got, and provide them with the angles they need for driving the DI pump. Sometimes you move the DI pump from the intake cam to the exhaust cam. If the cam is variable, so you move the cam, you also move the lobes on the DI pump, which all need to relate to each other. So all the applications are very different, so it's very difficult for us to do drop down.
Yeah, and I asked that because I actually got involved in that. Bill alluded to the fact that I was an OEM. I was an OEM at Honda, and I've since now done calibration for Honda engines, DI engines in other vehicles. And it's wishing I still had some of those contacts, but like you guys mentioned, once you leave, they really don't want you to ask questions of the engineers anymore. So, and that was one of the things we ran into is the ECU company we were working with on them actually didn't have the fuel pump defined correctly. So we had to go out and on the dyno kind of empirically figure out what worked. And it's kind of a pain. I would have preferred it to be on an engine dyno or something like that, actually have the cam out and be able to characterize it. But that's the biggest hurdle for DI to me is, everything else is kind of okay, but there's so many little things like that you have to calibrate. And for the most part, unless it's already been done, most guys aren't capable of doing that kind of calibration.
Yeah, everything is simple as when you tried it and you know what you have to do. So after a while, fuel and ignition timing becomes simple. Years from now, DI pumps becomes a lot more simple.
Yeah, as once we kind of get the stuff out there and guys to understand what's going on.
Yeah.
Okay, so walk us through the software a little bit here. This looks kind of pretty.
Thank you. So it's a little bit difficult because all our stuff are very user defined. You can add any channel, any gauge, everything you want. So this is our display screen. Anything you see can be changed in color, size, made into a strip chart, a gauge, a channel, and whatever you want. So this is our standard Godzilla screen for our dealers of the system. We got oil pressure, all your regular stuff here.
You know what? It might be good, to go into like something basic that all these guys will go into like the fuel and spark table. So this is like the display screen that you'd see on the dyno, or if you're reading it.
Sure.
But
obviously completely configurable there. You can tell that's a really nice IDE. So
can you offer an output test mode on the ECU?
Oh, hang on, Marky. Yes. Hang on. Output test mode. Do you have real-time calibration of the fuel and spark tables so we can steady state on the dyno, or do we have to flash the ECU in between rounds?
You do everything real time.
Sweet.
In the display screen, you can change the spark and fuel directly. It's not visible because we are not connected to an ECU. So I think I'm just going to go into some calibration here from something. I gotta see.
Don't let them see any of the top secret stuff.
I know.
I couldn't help but notice, obviously, that there's a lot more engines that you're already providing this on. I see Corvette right there, than just the Godzilla 7.3. So as you guys move this further into the marketplace, is there going to be a set of engines that you're already going to be available for? Is that part of the plan?
Yep.
Yeah, the you know, this controller existed long before the Godzilla existed. So it was something that was available, easy to use, and, you know, worked real well for myself and I think Todd on the dyno. So that's what we used. And again, there's many other systems, you know, out there that are really good as well. But, you know, again, the focus of this discussion is on the OBR. So, you know, I think they have, as you mentioned, they have applications that I think there are very few engines this hasn't been on at one point in time or another.
Yeah. We've been working with Ford for, I think, 21 years or so.
And other OEMs as well.
In different continents.
Yeah, just looking through your site, it looks like you've got pre-programmed units for what, the Godzilla, the 7.3, the 5.0 Coyote, the 5.2 Ford, Voodoo, GMLS, and most of the Dodge Hemis. And I noticed you guys also have harnesses pre-made for LS as well.
Yeah.
So all you guys,
awesome.
LS guys,
Not that we want to run one of those anymore.
Pay attention.
Here it comes, man. I'm already like private messaging the guys. No Ford jokes, man. No Ford jokes. Let these guys do their thing. Well, but honestly, the truth be told, the Godzilla, you know, Bewley on here 2 years ago and Fowler both were like, "Hey guys, this new engine they're putting in these trucks, that's got some serious junkyard swap potential. I mean, that's probably going to be the thing that overtakes an LS because of all the extra displacement you get with an engine that's the same physical size." Which, frankly, for the last 20 years of Ford, that's an absolute 180. You know, the last 20 years, I'm used to getting an engine the size of a you know, like a 900-inch Sonny Leonard, but it's good for 289 cubic inches in actual displacement. So that's one of the neatest things about the
guy who's swapping a
73.
Coyote in after the 600-inch big block into the 71. I appreciate this completely. Yeah, I should have waited maybe.
Look at this. All right, good display here. I like what I'm seeing.
Yeah. So, is there anything you guys particularly want to see? Fuel and spark tables, maybe.
So we got a fuel table going on here. It doesn't look. We don't have too many fancy colors, but it's very easy and quick to work with.
No, this is very easy on the eye. Okay, now can I edit on the 3D table, or do I got to do my editing all on the? I guess given the space you have, the real estate there, so you can highlight a block and raise and lower an entire block. You can interpolate between points, things like that.
If you want to go linearization from one place to another. This one hit L, and that does
very much like Fuel Tech editing here. Oh yeah, okay.
If you want more breakpoints, you can put in
very easily
plus hit minus, or you can see how many. That's the total amount of breakpoints we can have. Every time you insert a new breakpoint, it automatically interpolates between them. So if you don't want your 2,500, you can delete this guy, or you can insert.
We'll go slow
without mangling the table.
Just walk through it and then add one and walk through it.
Yeah.
Just a little slow.
So I'm gonna insert a 2200 breakpoint, and that will automatically interpolate between 2000 and 2500.
Holly, are you paying attention to this? Sorry. I hate changing. I mean, that's
too,
the
man. Inserting
God, it drives me nuts. I don't know what Mtron does, but Fuel Tech is pretty good like this about filling in the blanks.
Mtron and
sort of.
let you do it, but if you do it in Link, it has a way to do it, but it's really messy. AEM does not. You have to delete and rebuild your whole table.
This is nice. Just for the more novice tuners out there that are listening tonight, this is. These are tools right here that he's showing that make tuning this thing on an engine or a chassis dyno go super simple. Once you get familiar with, okay, I can highlight a block, I can raise it, I can interpolate between 4 points, I can go high to low or column or just rows. I mean, I can see here that this is handy for real-time tuning. So obviously this is developed by guys with a lot of years.
Johan, how long would you say it takes to get one up and running and let's say 90% tuned? After an engine starts on the dyno.
Oh, if there's a dyno, if we are talking fuel and spark and not idle speed, because that usually takes a little bit longer before everyone is satisfied. Half an hour, I would say usually. If
half an hour.
If there's no data in there, but usually I don't program fuel at all. It handles itself. So the important stuff is to get your controls right. So Lambda closed loop is the only thing I actually work with. I'm gonna make this a bit bigger. Closed loop control, you just key in your Lambda target values. I don't want to save the fuel table. So key in whatever Lambda target you want.
And then talk about how it works.
After this, there's a PID controller. I don't know how nerdy we're gonna do this, but
Go super nerdy.
okay.
Go nerd. Yeah, we know what PIDs are here.
Okay, so there's actually no D's in here, so it's just a PI control.
Proportional integral, yep.
Proportional, which corrects straight off an error immediately. So the more error you got, the more correction it will do. So
yeah, and for everybody else, you notice they don't have to use ginormous tables with the same number of bins as, say, the fuel table, you know, for your target air. Yeah, so okay, like it so far, I love it.
So the more speed you got on the engine, the more aggressive you can be on your O2 controls. You got more airflow, you got less delay, so you can be a lot more aggressive. In idle speed, you got huffing and puffing air going in and out. You want very slow controls on that, or as fast as you can go without starting oscillations in the idle speed. So we usually got numbers like this, small numbers in the low speed and higher numbers.
Sure.
Same
so
thing
let me tell people, that guys, let me translate for the Holly crowd out there. So you guys, the Holly crowd, you're familiar with just proportional integral and derivative, or your PID gains for things like boost control, idle spark, they're proportional integral. What he's got here is a way to change the terms. You're changing your PID loops based on load and RPM, which is really cool. There's a lot of reasons why you want to do it that way. It's a little more complicated, but you could
putting in a
really
zero.
fine tune it.
So if you put in 0 in proportional, put 0 in integral, and you got no PID control in this particular speed load area.
Nice. Okay, so you can lock it out if you need to at idle.
Yeah, so for the guys, there's a couple other ECUs you kind of have to trick it to not close loop at idle, like on a big cam or something like that, where we know our lambdas aren't correct.
Yeah.
That would be the way to do it here, is just zero it out where you don't want control.
Nice.
A separate single value just for idle speed as well. So when you're in the idle speed mode, we got a separate number just for proportional and integral in idle speed.
What's exciting me about this is the fact that you have what's typically a motorsport style user interface, and obviously a really refined one. But we're accessing real-time OEM grade fuel model here. Okay, so for the listeners, that is the hugest deal ever. When 100% of you is actually
go down the math channel.
I'm going to mute Barnhill here before he goes off on a click. Okay, so anyway, one of the things I'm noticing is that, like, all right, these guys have a deep OEM experience level, which is a huge thing, but they have an accessible interface. Like if you started off on big stuff or Holly or Commander 950 or anything back in the day and worked your way up, this is something I would be comfortable working with right now. Just by looking at this, I can tell.
It gets a little bit more crazy because we got self-mapping as well. So all the correction that the ECU does gets saved in a separate calibration, which we call a learn calibration.
Okay.
I can open.
So the self-mapping feature is kind of like auto-calibrate.
Yeah.
Understood. Yep. It targets a lambda and then it puts in whatever in the fuel table or whatever correction to the existing fuel table that it needs, I'm presuming.
Not in the existing fuel table. In a fuel table that got the exact same price, the exact same breakpoints, and multiplies through the two tables.
Yeah, very much like the Holly Learn table, but only probably a lot better. But go ahead.
Now they, I think they.
Is there a definition for the weighting on the long term, or the correction table, whatever you want to call it? Like how is there like a weighting of like a if it's like how the long-term fuel table works?
Is there a gain for how quickly it will build that correction?
There's the word. I don't know why I couldn't think of gain. Yeah, so it's like a gain on the long term of how quickly it applies the correction back to the map or saves it as a long term.
Activation, time delay, learn condition valid after this amount of seconds that you key in.
Yes.
Okay. So let me ask you this. So let's say I was on the dyno.
Yeah.
And I was doing a 300 RPM per second pull.
Yeah.
And let's say I was doing it at, like we did, at 10%, 30%, 50%, 100% throttle.
Yeah.
would that be adequate time for it to auto learn, or do you have to go more steady state than that?
That depends on what happens on the dyno cell, because you key in the times, how fast do you want it to work? You can see that in the software. How close to the center of a breakpoint do you have to be before the actually gets valid? Doing the quick dyno runs, I would usually not do self-mapping, because the closed loop lambda control is so fast that you just go. We spent 10 minutes.
Yeah, it's not long.
Yeah, when we went from NA to the twin turbo, I think we did 10 minutes of ECU calibration. That was it. We added a new breakpoint at 1 bar of boost, 15 psi, and we put in twice as much fuel, and that was it. Then I just relied on the
O2
lambda correction in the O2 sensors.
But I'm
No
saying,
kidding.
If you want to get that to a customer to have a good fuel table, so it's close to start with. So you did want it to auto calibrate.
Yep.
How would you could you do that?
Yes, definitely. Yeah.
Yeah, I guess the what I'm trying to get at is, you have guys, as soon as you say, oh, you've got an auto calibrate, they'll throw it on their street car, start it, and go try to drive it on the street. And when you start seeing a lot of transient loads and stuff like that, that's where dialing that stuff in matters a lot.
So that's why we got these called disable if you got transient.
Okay.
And there's
that
time
stuff
to
like that
reactivate after a transient, so you can wait a certain amount of time after you let go of the throttle or accelerate.
Pretty comprehensive right there, actually, just looking at that list of options. Yeah. Cool.
It's
I'm
always
looking at it. Go ahead.
Go ahead, Bill.
Oh, I was just saying, I'm looking at the list of options. There were a couple that jumped out at me that I wanted to, in case other people are doing the same thing I'm doing. It's a little harder to read on YouTube. And by the way, listeners, we have no Facebook feed right now. Is that correct, Scott?
That's correct. For whatever reason, Facebook changed their interface yesterday morning, and we went to set up the events, and it shows up as an event. It's a public event. People are having trouble finding it, so we told everyone. I made an announcement to get everybody on YouTube. We do record the video though, so what we'll do is we'll reload it back up on Facebook when we're done. So
Okay.
it's no problem. And meanwhile, we've got the large YouTube crowd listening in and firing their questions off. So
Yeah, and we'll get to a bunch of those questions. I noticed a couple of things here that sort of jumped out, like gear shift. Are we saying that there's transmission control in this?
There's transmission control, but it's not for your regular automatic transmission. This is a full-blown race pedal shift system.
Have you done BMW DCT control?
Not like a dual clutch.
Yeah.
We do full throttle gear shifting where you do not touch the clutch, and it does mechanical engagement in such a fast way that all your gear is perfectly smooth. We do
Stuff we were
downshift.
showing off on the Janetta last week, that kind of stuff for the listeners that are.
This is, of course, a little bit better because it's.
One of the tables that you had open, I'm going to call it a table for want of a better term, was oil pump control. The 7.3, is it using oil pressure to control cam phasing or something along those lines? Is that what that is?
talk about that control a little bit for us,
Yeah.
please.
Go to variable camshaft timing. Again, it's a PID. Well, it's got the D as well in here. You put in your target camshaft timing. You start out with a duty cycle, maybe 50%. After that, you just let the PI control or the PID controls handle the rest. Of course, you need to TDC the cams. So you need to put in the actual numbers. The same thing as you will TDC your timing. Then you have to TDC your cam.
So, but in short, so the oil pump is independent of the cam timing.
A little bit.
Because you do control cam timing based on a feedback loop on the cam
On the
location,
cam's position in real time.
the cam position, right? So there's a separate solenoid from a very simple perspective that
Is that a
will
simple
inject the-
PWM circuit to advance and retard the cam, or to direct pressure, I get to oil flow to the actuator, or is that a typical PWM setup, or is there anything special about that?
It's a regular PWM. I don't know how it works inside all the mechanic parts. I only know from the connector and out. That's
So for the simple guys, is there a recommended locked position or a default? How does the engine run when you don't have that control?
Well, it doesn't run very well in idle because when you put in 0 cam in idle speed, it will idle. Open the throttle more, everything works, of course. But give it 20 degree of camshaft timing, then in my opinion, it idles a lot better.
Yeah. I don't know. Will it run if you unplug the sensors?
Yeah, it goes to the parked position.
So that's fully
and
advanced.
stays there.
Yeah, there should be a parked
So
position.
to go to fully, so that'd be fully advanced, which is, so it has a 50-degree range.
Yeah.
So it'll be in the fully advanced position, and yeah, you won't get any of the retard. And I think most with the stock cam, it like to run around 14 to 22 degrees retarded, right? So you could see it'd be really, a lot if that cam's advanced that much.
And we're talking power here, not emissions.
Yes.
Yeah.
Understood. Yeah.
Right. Can you use cam timing to assist with how fast the turbo spools? Remember, I'm the NA nitrous idiot here, so I know nothing about.
No, I'm sure they can.
But it seems logical that you could. And then other ones that jump out are things like traction control versus launch control. Obviously, this is set up for. Yes, we could do something simple like drag racing, but we could also do road racing and drift and all of those things as well, correct?
Yes. That's where I think it all started in racing, and that's that's always the fun part. That's the racing part of it.
But you guys started with road race applications,
Yes,
right?
yes.
And in Europe, with what type of automobiles in Europe?
Anything, all the BMWs 25 years ago in England, Corvettes, we got prototype Le Mans cars in all sort of form and shape that runs these systems. Small 1.6 liter naturally aspirated rallycross cars with 240 horsepower. It's yeah.
So that's why you can see some of the paddle shifting and all those controls are in there, because again, it started mainly as a road race software and system, and then now using applications here for street cars or swap kits.
Every time someone wants something because they think their car will be better, we look into it and we update the strategy, so you don't have to build math channels and come up with your own ideas. So we make it a part of a strategy that's fairly simple to work with and got names that you can understand how to use.
Do you have the ability for math channels for those times when we're at the track and we're like, oh, I need this now for when we do need to make our own thing?
Oh, I can barely hear you now.
Okay, what he asked is...
Oh, I fully hear him. Sorry. No. No, we get...
Danish humor.
Yeah, okay, sorry.
We got a little bit, which is not really math channels, but we call them universal outputs. And you can turn any output on and off depending on a lot of variables.
Okay.
But usually we try to have a strategy for whatever you want, or whatever application that's being used in motorsport.
Yeah, so I guess my background's road racing as well, but I actually work and crew for a bunch of professional drift teams. We wind up doing a bunch of really dumb stuff, either to get around some rules or to get some weird control that I never thought we'd need till we're at a track and we have some stupid issue that I need to solve right then and there.
Yeah. Yeah, so no completely user-defined math channels. There's always a lot of ways you can get around it, assign one strategy into another one and go in and out.
Yeah, so you're saying you can set like basically Boolean logic to turn things on and off, and I can, I guess, stack those in a certain way to make a trigger happen when I need it to or something.
Yeah.
Okay.
I noticed there's a kill switch menu, for want of a better term. Does that also mean that there are outputs for, I'll call them as a simple term, warning lights or an oh shit button or those sort of things as we call it, so that you can notify the driver that, there's some sort of catastrophic thing like no oil pressure or whatever else it is?
Usually people that does racing, high-end racing, they got dashboards with all sort of logic for different warnings and alarms in there. we can always use our universal outputs for creating something. But not too many warning stuff. We got other ECUs that will do that. That will give you like a mil blink code that will show you the map sensor is too high or too low in voltage, so you know that one is bad, or the TPS. So,
well, the dashboard too, right?
Yeah,
So,
the dashboard will do all that for you.
Yeah.
And that's what people use.
Any CAN bus
Any
dashboard.
Yeah, any CAN bus. Yeah, we got free CAN bus universes in it, so you can run different speeds or different units. Sometimes you don't run your whole vehicle on 1 megabit CAN bus, but some of it is 500 kilobits, some is 1 megabit, so we can connect to multiple parts. You can also connect to computers to one ECU if you want to be if you want to program fuel and ignition at the same time. That's also possible.
Oh, that's
How
interesting.
programmable is the CAN bus? Say if I want to use, I've got this CAN bus device, I know the output CAN IDs and all that for it, and vice versa. I want to output from the ECU to my stock vehicle ABS or something like that. Is that all programmable?
Everything in our system in the user defined, there's a default version, which is just like OBD2 protocol. It shoots everything out in a more or less standardized way. Then you got user defined, which is 2 bytes starting from ID 300, and then it just goes up. You define where do I want to send out RPM, throttle, any of the thousands of channels, any math channel going on inside the ECU. The integral value of the DI pump, if you want to see that in the display, then you just put that into whatever ID you want to send it out through. And then we got a few options where often used ABS systems, you can tell it I'm working with this ABS. You can't see what's going on, you just activate it, and then it works. Same thing with a few different types of dashboards. You select that type of dashboard, and then it just works with that protocol.
Is there any programmable CAN input? Some guys get really attached to some specific CAN device, or I've got some weird thing I'm doing that I'm trying to bring in some part of my factory. Like in my case, we've repurposed buttons that come over the CAN bus in a factory car to activate stuff in the ECU.
So everything at the moment is default ID 500, and we got 16 CAN input channels, which gets treated as an analog. We do 12-bit, though the ECU handles them as 10-bit. All the inputs are 12-bit on analog and CAN bus, but to keep it simple, it's 10-bit because that's what people are used to. And if someone wants more resolution, like some of the OEM manufacturers, they want 4,000 steps on a throttle body, then just enable that.
So in other words, I saw 2 thermocouple sensors. If we wanted to have 8, for each of the cylinders as exhaust temperature sensors, that could be connected directly to this?
So the list I got open here is an input. So you define where is my air temperature, where's my anti-turbo lag, where's my brake pressure, front brake pressure, where's my calibration map switch. Does that come from analog? Does it come from digital? Does it come from CAN bus? So you can mix and match every single input with every single.
So the nice thing here is I can just pull the straight CAN ID just for my input, rather than have to completely decode an entire CAN string and then tell it where it is, or go through a translator, which is what I have to do now, like an MSR translator or something.
So let's say if you want 8 thermocouplers, and those 8 thermocouplers not supposed to do anything in the strategy, they will not change your spark advance, they will not change your fuel, they won't do anything. You just want to see them. You just send them in on ID 500 and 501, 2, and 3. Then you got all the data. But in our strategy, we got 2 which can be defined for changing spark advance or lambda target. So if it starts to run too hot, it can put in more fuel if your exhaust temperature starts to increase. So that's because it's used in the strategy. You can, of course, connect anything you want, but these are all the inputs used in the actual strategy for something.
And you said that the CAN default, it's just defaulted 500. I can change that to whatever. So if I've got an AEM EGT box that I already had, I can just set that CAN ID to whatever the AEM or whatever device I'm using is outputting?
No.
Okay.
If it's needed, we fix it in the software if there's a good reason for it. then we change it.
So right now you would need to change, and there are plenty of other programmable out there. You need something that can output on ID 500 to come in. Okay.
Yeah. You can also get one of these guys, and that will modify all the CAN bus. Oh,
Okay.
oh, sorry. Okay. It's also a good little, oh shit, I swapped 2 wires, and then you can change them in the calibration, no matter if it's in temperature or linear input for whatever sensor.
So was that just a CAN IO box, basically a CAN translator, CAN box you're holding up?
It's do we need to do something to see a video here? Stop sharing.
Well, what does it do? Yeah, just what's the box? What does it do?
It's our power control module. It got analog
Okay.
inputs, CAN bus in out, and then you got 1,000 amps that you can run through it for different
Okay,
types
so
of
yeah.
outputs. Yeah.
So you guys have a PDM that will,
Yes.
okay.
Which has a full CAN router inside as well.
Can you talk about the pricing of that PDM? Is it something currently available that our
Yeah, I
racers
think,
could buy? I know plenty of people looking for them.
Looks like
The new one here, I think,
570 based on the light, and then up from there. According to
it
your
should be on
website.
the website, I believe.
Yeah, the
I'm programming
32
in
channel
wires.
PCM2 light you guys have listed for 1570.
Yeah. That's our light box. The other one is a full motorsport enclosure with motorsport connectors.
You call it a light, but for people that have priced out, an EC Master or something similar, it looks like, what do we have? 22 up to 17 amp outputs, 8 up to 25. So this is what, is this a 32 channel? Or 34 channel?
Yeah.
So this is a 34 channel. So, yeah, it's about $300 to $400 more than some like ECU Masters, but you get more than almost double the outputs. And the 825 amps is huge.
The electronics inside, is actually the same as we use in the bigger box. The connectors are just much cheaper to work with, and that's why the current is lower. So you can run more current through it, but you might melt the actual connector housing.
That seems to be most of the issue with most non-auto sport connectorized PDMs, that it's always the connector that's the limitation.
Yeah.
So I'm assuming on the high amp outputs, you guys are doubling up pins on the light to get that much amperage out of a single output.
Say it again, sorry.
On the PDM light, I'm assuming like on the 25 amp outputs, you're probably using multiple pins on the connector to get 25 amps. Okay.
And the current draw that you see on the website is if you load all outputs at the same time, or every single pin in the connector, actually. We haven't melted any yet, so I don't know what the limit is yet.
So here's a kind of an alternative question. So what do you have? What about documentation? Where are you guys at on documentation?
That's on the download on our website. There's a
Do you feel like it's solid enough for someone with some calibration experience on other third-party ECUs could be able to take and run with?
It does not tell you how to program the ECU. It tells you how it's working. So there's not a lot of help to get for helping you how to program. Usually we work with some dealers or some automotive manufacturers in some way. We train whoever wants to buy our system. They get a full day of training with the system, and that's usually enough. And then they just call us when they got problems.
That's probably better than documentation, really.
Yeah,
some hands-on training.
It's that's a software for the ECT, the ECU programming here.
Hey, Todd, I know you were looking at some of the questions online. Did you want to get to any of the online questions?
Oh, yeah.
Well, I think this is a good transition because guys were having trouble downloading the software here. So they just wanted to see, they were looking for a particular file.
XIP?
Yeah, you can back up to that part.
This ECB client.
Are you guys looking at the questions on the YouTube? Is that
where that's
the only place there are questions tonight? Yes.
Just a couple.
So to run the software, you will need to download all programs here on the software engine management. So you need to download the communication server and the engine management tool. Maybe also the driver. I'm not sure actually. I always install all of them.
There's somebody saying they tried and it's missing a DLL, which tells me they probably didn't install the rest of the packages that they need. So I'm just gonna go through some of these random ones that kind of catch my eye. So the tank is asking, can it self-learn mechanical timing much like the factory ECUs do? Is there a crank learn procedure, or is it strictly mechanical key in the tooth angles, things like that? How is the Reluctor set up on this, and how do you validate ignition timing?
Yeah, you will have to do it the mechanical way. Key in the value that you want and take it with a timing gun. Per default,
Understood.
They all fire right at TDC until you hit the crank to run threshold. So no matter what you key in the software, it will fire exactly at TDC, and then you can check it like that.
Very much like the others. So architecturally, is this multi-processor or monolithic or multi-core, or do you have a dedicated time processing unit? Can you talk about any of that?
I know there's a dedicated time processing unit.
So hyper accurate ignition timing at all times. That was what I wanted to get
all
at.
programmed in. Most of it is assembler programming, which is very low level programming language, which makes it very, very, very fast. Yeah.
Cool. Excellent. Okay.
Which is also why we got our calibration works a little bit different than what you're used to. Probably we got one we call the setup calibration. That's where you choose amount of cylinders, firing order, which engine are we working with. The in and outputs, things you will never change while the engine is on a dyno or on the track. The rest of the calibrations, that's all your fuel, ignition, cam timing, oil pump, pedal shift, tracks, whatever you got, which is why it can go between different engine calibrations while driving.
Okay, right, understood. Okay, so on the fly, no less, yes.
System.
So I noticed that there was a pit lane control. Does that also imply that you could put in, if you've got a driver with the red mist and he's on the warm-up laps, you can limit what the warm-up lap tune is and that sort of thing. And I presume, therefore, this is set up to can be controlled from the pits as well as inside the car?
Not from the pit. Well, if you got communication through CAN bus, then the CAN bus can control your pit limit speed. Usually it's set up so they don't get a fine when they're driving down pit lane. You're only allowed to drive 40 miles per hour. It controls the electronic throttle body if they got that. If not, we can retard ignition until a certain amount. After that, you start hard cutting so they don't speed.
Dependent on driver input, right? Use a pit lane speed limiter button or a switch to enable
or is it
pit
use
lane
a
mode.
transponder?
Yes, we try always to use a momentary button, because we see quite often on the track someone pushes a toggle switch and they come in and complain, and we have to push the button.
I have a lot of fun stories about that, actually.
That's pretty smart, right?
Lotus 211, they spent 3 days trying to figure out. They bring the car to the dyno. I look at it and I push the pit limiter button, and all of a sudden the problem solves.
Yeah.
Brian, why don't you have video tonight? Are you breastfeeding or what's going on?
No. So I told this to Scott Evans. We took all of our cameras from the shop to the track, left them in the trailer, and then they went home with one of the guys in the shop. So we don't have any cameras in the shop for any of the dyno stuff or any of the stuff we're doing. So I took my camera in today, and of course I took it in today and forgot it.
Understood.
So I just ordered 4 cameras. So one.
We'll forgive you this time. Oh man, you should have said something, because that Akaso camera, there's actually one for a few bucks more that's infinitely better.
Oh really?
But, yeah, there's one for
we need
what do we
6
pay?
or 7 cameras for the
like $130 for that Hero 7 clone, and it ended up being a good extra money. But yeah.
Half of these are going to live in the shop on the dyno rim, so.
No, that's fine. They're going to get abused.
Did you guys want to look at some of the dyno runs and stuff? You know, I don't.
Yes. Anything else you'd like to share? We've probably geeked out too hard on the controller, but Johan,
I've got like a million other OBR questions if you guys have time.
I know, me too. We're going to have to take those offline though, because I want to get my hands on one of these so bad I can taste it.
Universal membrane panel that we're going to have to talk about later.
Oh yeah. Oh, I love that.
Yeah. Cool.
Ryan, while we're pulling up video, can you clarify something that was said earlier on? You were talking about on the dyno, and you were converting over from your NA pulls to do the turbo pulls. And the first comment was that it took like 15 minutes to do that. And I got the sense that the implication was you were actually able to use, and I'm using this phrase with air quotes here, learning mode stuff with the PIDs in order, because you had built a fuel table NA, you were able to use that to essentially build the fuel and spark table for the turbo pulls by doing some step pulls. Did I hear that right?
Question.
So when we were at
When we were going from the NA tune-up
Yeah.
to the turbocharger
So
tune-up.
yeah, fuel is quite simple. That's just if you do double pressure, you put in double fuel. So I just made one extra breakpoint at 1 bar, 15 psi. Copied the fuel from naturally aspirated and multiplied with 2. So that was.
And then use the feedback from the.
Well, so he's got what they're saying, Bill, he's got a solid enough fuel model that he knows at 15 pounds of boost, it's going to be real close to double the fuel consumption, right? Mm-hmm. So he knew where to put it. And given that their fuel model is so solid, it was within I believe Dave told me plus or minus 3% on the guess, which is ridiculously good because hell, that's probably, the barometric conditions are going to move that around enough, that same amount. Yeah. So impressive.
I actually didn't do any fuel learning when we did that. The closed loop lambda control is so quick. I just data log and let it run. And I only keep an eye on my closed loop lambda correction error. So if lambda is not equal to lambda target, there's a problem. And that's when we stop. So we can always after treat it. We got some software where you can build your calibrations from a data log, but only if it's good enough, only if it's within your tolerances.
Yeah, I guess the thing that jumps out at me looking at what's on the screen now is NA. This is still, I use the terms over square and under square motors in a different way. I know there's the one where we talk about bore versus stroke, but in this case, we're producing NA more torque than we are horsepower by a good bit, over a very level torque curve. And then
look at that curve, man.
Yeah,
I know that's
yeah,
the
if you want to call it that.
Want.
And then you look at the turbo, and it's still a situation where this engine is producing more torque than horsepower. So we're way down here in the that horsepower peak is at, what is that, 5,700 or 5,800 or something like that. So again, these are very big numbers at very low RPM. And that's what I think is talking to what the ultimate.
Yeah, I mean, I'm seeing optimized cams, naturally aspirated 800 plus pretty easy. Just looking at that curve, knowing what's going to happen as things get developed and you give up some of that. Look at 3,500 RPM, man. Is that 475 foot-pounds? I mean, God, that's awesome. And that's just all the stock. Heads,
so one
cam,
thing
everything, right?
I really like about this engine is the price tag on it. If we compare this to, I think I found one here that was roughly the same. This guy, that's a $15,000 engine. Plus, then you need to add on turbochargers and all the other stuff. And if you just look at just the power on those two, that's just crazy. You get a lot of power.
SR20s are garbage to make power on. You got to put 15 grand in to make anything. I like SRs.
They still shoved in $15,000 of parts in the engine and a turbocharger on top of that, and the other one is stock.
Put up a chart with it next to an LS7. That would be more of apples to apples.
It would be.
Yeah, I don't know if we have.
Well, I guess we're talking. What's the price tag on the crate engines of these?
Well, they're comparable.
10,000, isn't it?
Price tag.
They're not bad.
Yeah,
their crate engine prices are not bad.
Yeah,
LS7's I guess LS7's a good size comparison, but my question's going to be where these wind up. We're comparing this, horsepower per dollar, right?
Yeah.
So,
let me help.
are these
going to question?
He's got an answer. Go ahead, Brian. Go ahead, guys.
The crate motor, people are selling them between $7,000 and $7,400, and that's
complete.
Complete. That's complete. Coils, throttle body, intake manifold, exhaust manifolds.
Holy
complete,
shit, that's
ready to
cheap.
drop it.
Yeah, that is
Yeah,
cheap.
for a brand new
That's
crate
dirt
engine. So,
cheap.
I mean,
Yeah, I would
that
have
means
run,
that
I
as
would have
these
run
start
LS,
seeing
but
dropouts-
there's just too much money.
Touche. Wow.
I
Look
like
at
it.
Bill over there, man. Bill's on mute, but he's having like cattle. All right.
No, but I
Easy.
mean, the thing is, people will say, you know, that this is so expensive, and hey, you're not going to compete with the $500, 200,000 mile junkyard motor. I mean, no doubt. But if you look at brand new motors that make 500 plus horsepower, that's a pretty good price.
Yeah,
And
like,
again,
that's
man,
where I
you
was
guys are
getting at
talking
with
about
that.
peak. Every time I hear a peak horsepower number, I think that's great if you race irrigation pumps or gas compressors or generators. But the average power just sitting there on that stock crate motor is effing ridiculous with the
Area
right
under the
converter
curve,
or God
like-
bless it, a manual transmission car. That thing's gonna move out
That's
with
the
that
thing.
kind of torque
price
curve.
wise, you're looking more at the LS2, LS3 crate engine. If we're talking crate engine to crate engine, so
That's
price per
correct.
horsepower. And
Yeah, but what's that LS2, LS3 got at 3,500 RPM?
that was going to be my point. To
It's
get
got
that
475
kind of power curve, you're
foot-pounds.
putting a roots blower on top of it.
Yeah,
So
that's what I'm
I'm
talking
an LS
about.
guy, but price per
It
dollar.
should be
price per
average
horsepower?
power per dollar
Exactly.
across the
yeah.
usable RPM range. This engine tears it up. That's
This
awesome.
Godzilla engine is an absolute beast, down even at 2,500 and 3,000 RPM.
Yeah, yeah. What do you guys think about the bottom end, the architecture of the engine? Since we got you guys here, is it? I mean, it's for a
It's
Super Duty application, so we know they at least they had it in their mindset. All right, this thing's got to be tough and it's got to tolerate steady state high loads.
It is very rugged.
Yeah. It's a forged crank. It's 6-bolt mains with 4 down, 2 cross, which is, by the way,
Oh wow, yeah.
obvious. Opposite what some of the LS guys say. Well, we did it at first. Ford was doing deep skirt blocks, cross bolted mains way back in the 60s, but pretty much every V8 from 1992 forward was at least 2 down and 2 across, but most of them were 4 down, 2 across from the 4.6 on up. So
Yeah, so
bottom is really
the LS guys forget about who won Le Mans in '66 with and all that.
Jesus Christ, he
stuff.
sounds like a
All the
Nebraska
people here
football
know.
fan. Sorry.
On this engine, though, one of the things that we did do is we put a set of mild ported heads on it, CNC ported that Dave Visner did in his offering. So it still has the stock valves and that in it. We did a Calais cam and stock intake manifold, dyno headers. I think
So-
and the VCT was limited to 12 degrees, and that made 600 horsepower and 600 foot-pounds.
Yeah, so it's still not going anywhere in terms of engine speed or any of that sort of stuff. So it's
No, that's 6,100 RPM. Yeah.
yeah, yeah.
It's lazy. That'll last forever like that. So, what about some of the third parties that you guys are working with that are coming up with parts for these? You had mentioned that there's already what, CNC programs for heads, there's rods, there's pistons. Who are you guys working with on these?
Yeah. So one of the things that when when the engine first came out, and as I was retired and pretty excited about the engine, I worked with Calais, who is extremely supportive. So they have several camshafts that are available. They have a real nice H-beam rod that's made in the U.S., not too far from really where in Ohio. So we've got cams and rods, pistons. Wiseco is going to be doing a shelf stock piston. So you're going to be able to get the piston, the pin, and rings, and they're going to do a 10-to-1 and an 11-to-1. And I think it's going to be on the order of like $950-ish retail on that piston set. Daily Engineering has a dry sump pan for it already. Valve springs are going to be coming early first quarter. So right now we kind of had to cobble stuff to get a little bit more spring pressure in it. But there will be a noted spring manufacturer that will have springs in the next probably 60 days. I mean, pretty much the only thing that really isn't out there today that I would like to see is an intake manifold. Team Z Motorsports has K members that will go into the Fox Body Mustangs, which of course I love. They are also probably within the next couple of weeks going to have an oil cooler bypass, so that for the pan. So right now it's got an oil cooler hooked up to it, but again, no one's really going to use an oil cooler on most race cars. I mean, that's when you're towing a 30,000 pound trailer up Davis Dam, you're going to need an oil filter. But most of the car applications won't. So again, and then as mentioned, Visner engine development, we've been working with them, and they kind of have several stages of cylinder head. Some people don't like it, the stages, because it sounds too simple, but it is simple, so keep it simple. So they have the stage 1, which just uses stock valve sizes. It's a CNC porting of the intake and exhaust. Also qualifies the combustion chamber. Then they have stage 2, which will go to a 2200 to a 2220 intake valve, and that is quite extensive work with premium seats and guides. And then as Dave's showing, this is a stage 3 head, which we have on the motor that I'm doing with the Whipple on it. This is a 2 1/4 intake valve, 1/700 exhaust valve. It's set up for shaft-mounted rocker arms. So this is a pretty serious piece. And that head there
looks serious.
Flow.
Look at that short turn there. That's cool.
And that
looks like those things look like they're meant to flow some air, but I'm the dumbest one when it comes to cylinder heads here. But
that thing flows. It's a stock cylinder head casting, flows 395 CFM on the intake side at 900 lift.
Wow. What size head bolts are those in there? They look fairly
13 millimeter.
Wow, that's impressive. So what's the weak link in a stock motor? Is it going to be the block with the water ports in between the cylinders like that?
Well, we're all speculating, right? I mean, because again, you got a stock engine, so yeah.
You're speculating. Sewell's fixing to find the hell out. Sorry, go ahead.
So, well, we are going to find out, right? With what Todd's doing, I mean, he's going to make a ton more power than he made. We're going to have the Whipple on one, and I'm looking to try to make 16 to 1700 horsepower at that. And so we'll, if it lives with that, it's going to be really good with a turbo. But to be frank, we don't know if the cylinder head combustion chamber, is going to be stiff enough, or if it's going to, start to deflect. I don't know if the head deck's going to be strong enough. I don't know if the block deck.
What kind of deck thickness does that head have? Do you know?
It's about a half inch.
Yeah, it was like 560-ish.
Todd said about 560.
I mean, most of the LSs are 375, so that's pretty good.
Well, again, we all got to remember that this entire platform is based around Super Duty trucks that'll pull a 30,000 pound trailer up a 6% grade for an hour. So I would expect that this platform generally will be more rugged than the engine that would come out of a 1500 series GM product.
Coincidentally, the feedback on the Ford truck groups, which I'm a member of a couple of those on Facebook, people love this. There's a lot of people coming from their diesels and are absolutely happy with the 7.3. And it even gets, they're not getting the most horrible mileage. I mean, there's guys towing big loads, and they're still getting 7.5 miles per gallon. But there's all people tracking their mileage and all kinds of stuff. I think the transmission is probably a big help, that 10-speed trans.
Yeah, it's really
whatever
good.
they're using there.
But you touched on something that I think is important. The whole purpose of this engine initially was to replace the 6.8, and it was strictly for fuel economy to meet the new CO2 regulations. So that was the driver of doing a new large gas engine in 2020.
And again, you guys are not directly connected. So no one knows, especially with the change in administration, what's going to happen with fuel regulations, and especially on the heavy duty truck side, because that's a little more interesting question.
Yeah,
Brian,
they're targets at this point.
I don't know if you guys know anything about, where any of that's going or hear scuttlebutt. I mean, the thing we keep hearing is kind of negative is that everybody's going to build electric cars. So this is going to be like the last pushrod gas engine ever developed ever. Are we being overly negative?
I don't think you're being I wouldn't say overly negative, but the one thing, and again, I've got a point of view, which I don't want to get political, but I do believe as soon as people start to give the full truth on electric vehicles, and you start thinking we make, near 90 million vehicles globally, about 17 million in the US, about 15 million in Europe, and you start thinking about mining the lithium for all those batteries, you start thinking about how you're going to dispose of these very carcinogenic batteries when they're come to end of life. And the reality comes to how much cleaner they really are. We like to be simple, right? I plug it in. I don't know I don't know how it got there. You know, I drive my car and yeah, it doesn't have any CO2 coming out the back or hydrocarbons or NOx. But, you know, to be frank, the electric cars aren't all that clean. I think sooner or later, some of that will come to light before you see the end of internal combustion engines.
Life cycle carbon out. Footprint and all of that. I live in California, so the issue with having an electric car here is my electricity might not be on enough to keep charging it all the time. So that could happen. So
but I do think electric cars have a wonderful use in major metropolitan cities like LA, like New York, like Paris,
Sure,
like London, where the NOx and hydrocarbons become very important from a air quality perspective in very, you know, crowded areas.
also when I'm only going to drive 4 miles to work each way and back.
yeah. So
in an hour and a half.
Are you guys, and this is for Merkel and Brian, for you guys perhaps, is in the short run here, are there going to be engine packages or stage 1 kits or some of these other things? So obviously for people that are, you know, have a vehicle that's emissions compliant, there's a different set of concerns there. But for the swap market or the crate market, are there going to be those sort of packages that you're going to be offering in the near term?
Yeah, you know, basically, you know, Todd and I both take cuts at this. You know, my website will probably be going live next week, the Willis Performance website, which is willisengines.com. And, you know, we will have on there the camshafts, the pistons, connecting rods, oil pans, cylinder heads, cam VCT limiters, control systems, all shown on there. And yeah, you know, and we will have packages. You know, again, I'm you know, smaller than Todd's organization, so you know, I like to bundle the parts and offer those for people to install themselves. But I do take on some customers for you know, for doing complete engine builds, dynoing their engines and sending them to them. And I think we got a really good offering for people that like that 600 foot-pound, 600 horsepower with a pretty simple, you know, upgrade of cam, CNC porting, and the travel limiting VCT. And I keep talking about this travel limiting VCT, and the reason that is with that 50 degrees of range, you can really get into trouble on the exhaust side. Because when the thing's cranking, if it doesn't lock for whatever reason, and you go to that full 50 degrees in retard, the piston only has to hit the valve once, and it gets pretty ugly.
You won't have it on a stock engine. But
Not
as soon as you get
stock.
more lift.
Yeah, as soon as you get more duration. So if you put one of like a, you know, like a 20, 30 degree longer duration cam, the exhaust valve and the piston like to be in the same spot at the same time at 50 degrees retard.
Yeah. So one of our listeners, Scott Russell, has posed this question twice. So I want to make sure we get to him. And he said he'd written you before, so you may know the name. The question was, are the chambers thick enough to withstand high cylinder pressures, you know, something where we're looking at 2 or 3 bar?
I think that was what we said. We don't know yet.
We don't really know yet, but the truth is we're going to find out in the next several weeks.
Yeah.
Okay.
So stay tuned.
Yeah. Yeah. Todd and his brother are doing exciting work with those twin turbos.
The truth is, when we hatched a plan to put the turbos on this past weekend, I was fully prepared to keep boosting it until it broke, but then it didn't, even at 15 psi. Yeah. So that was rather encouraging. But we're gonna keep working up the boost and changing the small things as they come along. Like I've mentioned, I think we were running out of intake valve spring. So we're going to start with that and then try and make 20 PSI. And we'll keep moving in that direction until we find out.
But even on 4 PSI, the thing was making 750 foot-pounds.
Sure, it's moving air.
You know,
well, yeah.
What turbos are you guys using? What turbos?
Thank you.
What turbos?
Yeah, it's the VS Racing 7875. I think it's a Gen 2.5 billet wheel.
And there's a very specific reason it's those turbochargers because they could be in New York at the same time we were there.
Yeah, that was something that we ordered because they were on the shelf and I was able to get them in one day because like I mentioned,
Perfect.
this whole
That's
thing,
fine.
this whole thing happened over a 24-hour period.
So
from idea
nothing
to-
is exactly idealized. I mean, looking at it, it looked like flipped stock manifolds, exoust manifolds, and all the usual
correct.
sort of just find a way to get stuff connected together and make it
Yeah.
work.
And the other thing that might be worth noting here is that I'm aware that these turbos are a little big for an otherwise completely stock engine, but we wanted to leave ourselves some room to be able to make a lot of boost at higher speeds as we start improving the other components in order to be able to do that.
Makes sense. So this is you guys will continue to produce results as you live with them. I've been
Yes.
appreciative, Brian, of your videos because your videos have been very forthcoming about what you found and what you ran into and issues that you came across, everything from, trying to put it in a Fox body and all the other things. They've been very informative. I think I've watched every single one of them. So appreciate that and making those available.
Thanks. I'm glad people enjoy them.
Yeah. So what's you mentioned you're gonna put more boost to it. What else? What are the other plans? So we've got really 3 different sets of offering. We've got 2 sets of engine builders here, and we have OBR. So will we see an OBR related package with those engines as well?
Yeah, absolutely. The OBR, I mean, it's basically there today, right?
Yeah.
So, and I think that the way that the package is set up is it's to work with the map sensor and the stock engine. Right?
Every stock sensor you got on, or any stock sensor you got on the engine is in the wiring harness and is being utilized. The wiring harness is all made of motorsport wires, which can handle very high heat, wrapped in very high-grade automotive tape. So as close to motorsport as you can go without putting a DR25 heat shrink on it and gluing it together with motorsport connectors. We use all the stock OEM connectors as well in the harness. So yeah, you don't have to do any fiddling, soldering or anything like that. When we started up at Merkel Racing Engines, we didn't even connect a computer or laptop. We just put it on and they pushed the startup button and did a dyno pull. There was no laptop connected at any point.
Yeah, we had that engine after the normal installation was made to the dyno stand. The installation of the ECU and the wiring harness was not more than a 10-minute job.
Yeah.
Everything worked. It just plugged right in. Connect the plus wire, connect the ground, and down the road.
So how much is your ECU package to run one of the crate motors?
With the harness.
33.50 for
That's
the wiring
not
harness.
bad.
And
With the harness?
Yes.
That's not bad at all.
Crap, with a nice harness? Are you kidding?
No,
That's awesome.
Price, yeah.
We're going to have to use this one.
More like a professional harness or a Tinkler harness with extra fuel pressure sensor, extra inputs and outputs for all the other stuff that extra boost controllers. We can do a fully sequential boost controller setup so you can run 2 individual intake manifolds with multiple electronic throttle bodies on it. So if you want to upgrade with 2 big LS electronic throttle bodies, you can connect that directly. If you've got a stepper motor for idle speed and a mechanical throttle body, you can connect that as well.
I mean, we're talking getting in the neighborhood of $10,000-$11,000 all in. That's pretty amazing.
That's cheap, man. I mean, that's
yeah. Well, we look at our
okay, good.
competitors online, and they sell a lot of cheap stuff. And if we want to be in the business, we gotta settle up and
Be
keep
price
the
competitive.
cost as low as we can on these parts.
I mean, for a really good quality harness like he's describing, that's awesome. I mean, if it comes with the harness and ready to go, that's
I think the only thing that's incremental would be the ego sensors, right?
Yes.
Yeah, you'll have to buy your O2 sensors. It doesn't come with a pedal. It doesn't come with O2 sensors. It comes with a little power wire. So you connect plus and minus, and you hit start, and it'll run. If you want to start programming, you have to do either an Ethernet connection or get our USB to CAN bus interface. So you can do live tuning and programming.
But the engine as it comes out of the crate is effectively mapped completely already.
Yeah.
Just to take a step back, you can do live tuning over Ethernet as well. It's not only CAN.
Yes.
Okay.
How much does a fully assembled Godzilla engine weigh?
Well, it depends. There's one of the videos are on that, because what we try to do when you weigh something, it's kind of like how much horsepower, what correction factor did you use? Does it have exhaust manifolds? Does it not have exhaust manifolds? So one of the videos that I did, I had a Coyote, a small block Ford, which was a 428 Windsor-based engine. I had the Godzilla. So I'm going from memory, so I'm probably going to be off a little bit on these numbers, but they'll give you pretty close. The Coyote was about 400, just over 400 pounds. I want to say 404. I believe the Windsor, again, equally dressed, was I want to say 440-ish. I think the Godzilla was 480-ish. I know it was, on that order. But if you check out Reverend Evans' channel and find that look for that video. We do have all the weights, and shown where I weighed them.
And you guys did dimensions too. I mean, you were measuring and doing. That's what I mean. Those videos were so helpful, because you had all that stuff and the sort of look at them here in front of me, comparisons and all of that.
Bill, this is making me wish you would have done your Coyote project a year later and then done one of these.
But I mean, that weight is in line with, say, like an aluminum head iron block small block Chevy. It's not out of line.
Yeah.
No, yeah, the block is pretty stout. It is, that block is heavy, but the heads are pretty light. I mean, especially when I compare it to like my SC1 heads, where when you pick it up loaded, so man, you got a chunk of metal. When you pick this up, the heads are pretty light.
Other questions? Anyone?
Anything online that you guys saw that popped that people were asking? Todd, I know you were writing some stuff down.
Yeah, I'm kind of looking at a few things here. Two of them I wrote down we had covered already. Dave, did you see anything specific in here?
I seen one question on the YouTube chat here. It was, what are the differences between an LS swap and a Godzilla swap, as far as how hard is it going to be able to fit in this thing? There's already companies out there that make, for a Fox body, a K member, which is
from Team Z.
Yeah. Team Z makes the K member. They make the motor mounts. I believe they make both solid and isolated mounts for it. And they're also, again, they're working on an oil pan update to maybe give about 1 3/4 to 2 more inches of oil pan clearance. I don't expect that probably until February to be available, though. But
is that pan, the stock pan, a rear sump, front sump?
Rear sump.
Oh, okay. So for people that are doing a lot of LS stuff that are already working around a rear sump pan, well, you're already working around a rear sump pan, so there may be some differences. It sounds like the pan rail is quite a bit wider than an LS. Is that a fair statement?
Maybe you'd be best to judge that.
Yeah, I imagine so. Probably not very, very much. So I have an LT in my car, which is very similar to an LS, and hopefully one day I'll put this Godzilla in my car. We'll see where we're at. But we also did a Cobra Jet, white Cobra Jet Mustang. That's also our group from Paul's High Performance. So we were able to fit a Godzilla in there. And that one ran, are they in the 9s totally, completely?
10 flat.
Yeah, 10 flat.
With nitrous.
With nitrous. I think it's a 200 shot of nitrous. So
when you say Cobra Jet, are we talking an S550 Ford Performance Cobra Jet? So one of the factory.
Yeah, it was a 2010 Cobra Jet.
Oh, it was a 2010. Okay.
That was also like a 2-day build, wasn't it? That one?
Yeah, that was a very quick build also. So, it's very comparable as far as ease of installation to an LS or an LT. Small block Ford, big block Ford, they shoehorn in these things relatively easy.
Yeah, well, given the deck height and everything else, yeah, definitely. What else do people need to know about the 7.3s and setting up with the OBR?
Oh, say it again. Sorry, I was reading the.
No worries.
I think what they need to know is that it's really easy.
Yeah.
I think, yeah. Well, yeah, I guess the crate motors are available. Ford Performance done a good job of getting those out. The OBR control system is available and, plug and play. And then there is a very wide variety of aftermarket parts available for it already. Again, I think that the two things that I would probably desire to be out there today would be the better valve spring and a more favorable intake manifold for horsepower as opposed to torque, because the truck intake, it's designed all around getting a lot of low end torque for the truck user. But those two things I think are the things that I believe companies are working. In fact, I know companies are working on the intake manifold. I know companies are not, in addition to Dave at Team Z, are working on other oil pans for more ground clearance. But the parts are there now, and you can go.
Yeah.
Is it too early to know about little livability things? So on the Coyote, one of the things you first want to do when you start making more power is you replace the oil pump gears, for example. There's little things like that. Are we at the point where we know about any of that stuff?
We haven't failed.
I don't think we're quite there yet, but so far so good.
Yeah.
Okay.
Yeah, I ran the stock oil pump on that engine that we made. Again, that was a 12.5-to-1 compression, aluminum rod, mechanical roller cam with the Visner billet intake on it with the dyno headers. And we didn't quite peak because we ran out of injector. That made just under 800 horsepower and 7,600 RPM, and that was with the stock oil pan on it.
You mean you guys got the VS Racing turbos and didn't opt for the VS 210 injectors while you're in there, or what?
We had the injectors on the shelf already.
Okay, I figured.
Well, those injectors were from some other project.
They were from some other job we were
Yeah.
working on over the summer.
Right on. I like the looks of your dyno room, by the way. It's very well used, I can tell.
Yes.
It's like, all right, cool.
We've had that dyno room up and running for many, many years.
Yeah.
I'm looking at the bandsaw in the background. We just bought one like that from an auction recently, or very similar to it. A
The older the better.
Yeah, they're great. This one was milled in 47 or something, but hey, everything is still there and it works. You guys have been awesome. It's coming up on pretty late back.
We should let these poor guys go. You guys are heroes, man. We appreciate you joining us tonight. This was awesome.
But I know we're all hoping to follow up with you guys again sometime soon. I mean, I'm going to start.
Oh God, yes, yeah. I'll bug you, or you let me know if when you've got some updates. Let's get back on and talk about it. This is clearly I'm hopefully going to get my opportunity with one in a car here in the next couple of months. So we'll find out here. But you got me leaning towards the OBR stuff at this point.
God, I think that's a done deal, Scott. I mean,
for the money.
Like,
yeah. Okay.
I'll be honest with you. I'm looking at this looks like maybe the one that I convert the 598 and the Fox body to. I'm thinking. We'll talk more.
Yeah, I'm not going to say nothing.
Mark spent all day swapping turbos on an EcoBoost thing or something. He's not exactly in Ford mood today. It's okay. We'll need him.
I wouldn't get rid of a 600 cubic inch 385 big block for a 440 cubic inch small block.
Oh no, Mark, I wasn't saying that. I'm talking about using the OBR.
Yeah,
I'm talking about using the ECU so I can get rid of my Science Fair MS3X.
Yes.
Yeah. Does that make more sense?
Yes, that I'm all for that.
Okay, cool.
Is it a DI engine or PFI engine? PFI. All right.
Oh, it's program. It's port injected. Yes, port.
Yeah, we got
it. It's a traditional old 460 A460 based big block, big cubic inches, naturally aspirated. Bill's a naturally aspirated guy. It's all right. He's old. Just play along.
Yeah, I'm gonna die any minute now. But it's
he's developing Alzheimer's and
Bill. Yeah. It's a drag week car. I have 2 jackets, by the way, so I'm not complete.
Oh, I know. Okay. We pushed buttons. I feel bad. Yes, he has won his class twice at Drag Week, which is an endurance drag racing event that you guys know about. All you guys are drag racers, so you know what Drag Week is.
Absolutely. Yeah, we know we like naturally aspirated too. The tough part about naturally aspirated stuff, and I think, I switched from all motor naturally aspirated racing to the boost stuff, is there's only really 2 big places to race. There's NMCA, with the nice heads up NA10.5, and then Milan Dragway, which is local here, has an all motor class. But there's not a ton of places, but there's so much really good small tire boosted stuff going on. That's it's hard to pass that up. That's a lot of fun.
Sure.
Well, that's where I think
that's
this
cool.
Turbo 7.3 thing is going to be like, hoo.
Oh, I know, right? This thing's going to take off. I didn't realize, number 1, that it was that cheap. Number 2, that they had the controls figured out already solid. And number 3, that there were already parts available for this, and these guys are plowing through it. So please, in the coming weeks or months, let us know, guys. We want to get some updates. As soon as those numbers go up, we'll at least release it, talk about it, and if you want to get back on the show, anytime you want, happy to have you.
Yeah, just 2 more things I should probably mention is that one thing we talk about turbos, but there are 2 kits available supercharged. So ProCharger has a bolt-in kit for the Super Duty, and Whipple also has a bolt-in kit for it. So we'll be running a Whipple 3-liter on the engine at my shop here, hopefully within the next few weeks as well. So we could have a couple of variants of boosted engines that we'll be able to share.
So you're saying the Whipple and the ProCharger, those are already shipping kits that are like complete, ready to go, put it in your Super Duty?
The ProCharger is definitely out there and ready to go because I've seen them. And they were very, very proactive in getting that kit out. I worked with them, quite a while ago so that they'd have the details they needed for that. Whipple is due out right about imminent, if you will. I have one of their early superchargers that I'll be running that's set up more for like the factory supercar supercharger was set up, so more for efficiencies at higher speeds. But their kits are imminent.
Outstanding. Okay.
Yep.
So
you guys stick around for a minute because. Go ahead. Sorry, Mark.
Well, I've got one question I wanted to ask. Because you are retired engineer from Ford, you said you ran the department?
Yes. Yeah.
Who was in charge of designing the new heated tailgate?
I have no idea because I was the only powertrain guy.
Oh, okay.
I see how quick you passed the buck on that one?
I think
this guy's got 40 years of corporate. I can tell right there.
No, I think it's
he
great.
handled you like a boss.
Your hands don't get cold when you push them.
Oh, Mark, geez, that was a long way around.
Did you wait all night for that BS? Oh my God!
I waited all night for it.
Well, wait,
take a drink.
Have you noticed the back of the new Chevy 1500s? They got those 2 real openings in the back that people thought they were for exhaust, but what it's really for is put your forklift in so you can move them around.
Yes, indeed.
I like you guys.
All right, Jason, take us out of here, man. We'll let you guys stick around for a minute. We'll chat with you and wrap it up, but we'll let you go then. But all right, so thanks everybody for tuning in tonight. We appreciate it. Gosh, what was that, episode 143 or 4, something like that? We'll get this up on the podcast sites. We had problems with our Facebook live stream. It forces us to do this through an event now, and then only I can see the event for some odd reason. So I apologize, but I'll get that fixed, and it'll be available on Facebook. Also, currently available on YouTube. You can share the link, but talk to if you got any questions and you want to reach out to the guys. Any of the guys involved with this project, Brian, Johan, Todd, just hit us up or hit them up. Very easy to find these guys on Facebook, and all the 7.3 Godzilla groups are following them closely. So easy group to find. Thanks again on you guys for coming out tonight. We really appreciate it. Everybody.
Now our pleasure.
Thanks for inviting us.
Yeah.
Thanks for having us.
Awesome. All right. Sit tight. We'll talk just here in a little bit.